Good day, everybody, and welcome to Discover 2025. Thanks for joining us today. I am Omar Elisa. I'm a distinguished technologist with HPE Data Center Services. So what is HPE Data Center Services? We are a practice within HPE that is concerned with anything and everything that's data center facilities, space, power, cooling, high density cooling, air cooling, liquid cooling, power distribution, all the way from utility, transformation, high voltage, low voltage, all the way down to your power supply plugs. Anything that has to do with the physical infrastructure is our practice. Today we're going to be talking about the rise of modular data centers and how we are addressing artificial intelligence workloads. We're getting into aspects of workload placement with AI, how do we deal with powering AI, the challenges with that, as well as high density cooling. We actually have come up with an innovative solution. You might have heard about it at Antonio's keynote. It's called AI ModPod. That's actually what we're gonna delve into. Topics that we're gonna address between the innovation of the cooling elements, the power elements. We're also gonna get into costing, right? How do we place AI, and then how much does it end up costing us? How do we deal with that with these limited resources? So let's get into it, folks. We have to show the slide. I don't think I'm going to make any forward-looking statements, but hopefully that's all right. We also appreciate your feedback, guys, after this session. Hopefully you guys get some key takeaways from what we're going to talk about today. So for most of you guys who are in the data center business, placing enterprise workloads comes with its own challenges. Now think about AI. So placing AI is a challenge in its own because of the high demand that algorithmic computing puts on a high-performance computing machine that is actually extending the capability of existing data centers. So if you own an existing data center and you've designed it, let's say, for 100, 150 watts a square foot, which really translates to somewhere between 5, 8, maximum 15 kW per rack. Now let's throw AI at it. I don't care where you're getting your machines from. Now you're starting to see machines that are going to demand 25, 35, 40, 50 kW per rack. Well, how do you deal with it? Your data center can't handle it, right? So you come and you talk to us. So here's some observations about where power capacity is being deployed. We talk about 10 gigawatt of capacity that's going to be deployed in 2025 in major markets. But the fact that we can't escape, there's a surge in demand for AI. There's AI training, there's AI inference, and then there's the general use AI like ChatGPT, etc. So where is all this stuff running? What data centers is it running in? Is it running in your own data center? Is it running in co-location? Is it running in the public cloud? So we're going to get into it. We're going to talk about where AI is getting placed. And then we're going to get into costing, guys, at the end. So usually what we are seeing with AI workload placement is practically anywhere. That's for most purposes today. We're placing AI workloads. It doesn't have to be within your metro networks or within your metro cities. Most of the time it's not connected to a public cloud type of data ingest. So that's the geography element, which really opens up the ability for us to take the AI workload and the machines and put them somewhere remote where power is available, right? But the other demands that customers are making is they want to host AI in a responsible fashion. So they would like to be able to do that with hopefully renewable energy, but they also want to run it efficiently, and that's some of the stuff we're going to talk about. So they want to be sustainably responsible with AI. They want data to be secure, so there's a lot of physical security elements that comes with AI deployments. They want to do localization, so we actually have a lot of demands of localizing data like sovereign AI and things like that. Usually these are very critical, as well as data recoverability and some, fairly decent network connectivity where you need to get, data ingest and exit your data so that you can use it. So latency comes into play. So these are the elements. So what does it really mean? So in a nutshell, the things that we need to focus on is that in the current data centers that most of us own and operate today, we have a lot of limitations on the power and cooling aspects. So we need to solve that, right? So we have a limitation on how much power we can provide, density per rack, voltage levels, right? So Most of the data centers, even if you're running a tier 3 enterprise type data center, you're most likely running a 208 volt circuit, 3-phase, and then whatever your choice of amperage. At the end of the day, you're maxing out at 17 kW. Double that up, you can go up to 35 kW, but then comes in the cooling aspect, right? How am I going to cool my 35 kW by pushing, enough CFMs to actually cool that machine? And then, fine, if I can do that with some close couple cooling, good, I'm done at that limit. I need other choices. Other things we run into is budget and timeline. How can I deploy AI so fast? Do I have the time to renovate my facility? There's lead time to procure, design, permit, do the upgrades. Maybe I'll go to co-location, but again, co-location comes with some limitations because they may not have the capacity, as well as they most likely are missing the liquid cooling elements. So let's introduce our AI ModPod, okay? AI ModPod is a modular data center. POD stands for Performance Optimized Data Center, okay? POD is Performance Optimized Data Center. What does it mean? It means that we look at the AI workload and the HPC machines that you're going to be deploying, and we can optimize the design, the operation, the functionality of this pod to meet the requirements. So some of the requirements you might have is you're putting in a machine that runs, say, on hybrid cooling, whereby some components are liquid cooled, but other components are air cooled. So we can actually variate within this modular data center how much liquid cooling we're going to be injecting into the racks and how much air. And we can play with that. If we're going to be doing 50 kW or 100 kW per rack, we can play with that, right? So in most, say you're looking at a Cray XD, an HPE Cray XD, in most cases, you're going to have an in-rack CDU, and you're going to have the machines in that rack. You're going to cool about 70% of the components of the IT with liquid. But then you're going to have residual heat, 30%, that now we have to recover that by air. So what do? So we implement hybrid cooling, and I'll actually show you how that also works. So what's unique about AI? Why did we have to come up with this solution? What's the demand for it? The demand is speed, right? The demand is customers need to be deploying AI now, right? So what we're actually competing with whenever we talk about the solution is, I don't really compare with how long does it take for you to renovate an existing or build a brand new building. What I'm really dealing with is how fast the customer wants to be procuring the IT and actually having a place to house it. So generally, when you're looking at an AI ModPod, we can deploy that somewhere between 6 to 8 months, and that would be ready at the site. Now think with that timeline, 6 to 8 months, what it's actually doing for you is by the time you order that from HPE, you can actually be setting up your site. You can be doing your permitting, getting the site pad ready, getting your perimeter security, getting all the site elements ready to accept the ModPod. And then along with that, as you can see in the middle photo, you can actually be getting all your cooling elements, power elements implemented at the site in parallel, right? So practically in less than a year, you can actually have a whole data center stood up that can do hybrid cooling, upwards of 125 kW per rack, liquid cooled, air cooled, with all the capabilities to deploy that IT. So you have the speed, flexibility, but then let's also not forget about efficiency, right? Efficiency is really important. So when we think about, say you were running 15 kW per rack type of workload, today you're running upwards of 100. So the amount of power that you're actually consuming in an AI cluster, so what you guys see in the picture, that's about 1.6 megawatts. So when you start thinking about the cost, not only the CapEx of deploying this infrastructure, but you also have to think about the operational cost of how much power it consumes. So 1.6 megawatt, typically with HPC, I'm running upwards of 90% utilization, right? So every hour I'm consuming, 1.3 megawatts per hour. Multiply that by what's an average cost of 12, 15 cents per kilowatt hour, and you guys do the math, right? So if we can bring the efficiency, higher, as well as the utilization of the power and cooling, what I'm doing effectively is I'm reducing my PUE, my power usage effectiveness, and with a solution like this, we can get very near to 1.1. That is really highly efficient. That's almost perfect. So these are really the big advantages of why you would want to go modular, right, in an AI ModPod when you're doing AI deployments. So this is an IT module that we're looking at. So the anatomy of the AI ModPod is it comes in with the features of high availability. You can do that at a tier 2, tier 3, so you can set up the power however you like. If you have input power at the site, we'll take 480 volt into this IT module. We can shape that in whichever way you want. It goes into switchgear. It can go to UPS. We can have UPS back up just your management racks. If you want to back up the entire GPU IT workload, we can put that on UPS as well. You want to add generator power, we're able to do that. We can take it up to the tier 3 plus, which is enterprise level. Comes in built-in security. It comes in with network interconnectivity, IT hardware integration. I can't stress on that enough. So the beauty when we're working with HPE, our customers really love this because we provide the housing element, but also our partners at HPE are providing all the IT that is fully integrated into this data center as a complete end-to-end solution. You get fire protection, and then last but not least, you actually get supervision and control in a digital twin fashion, so you have full control of the facility systems within the pod. So the capabilities that we also have and why the modular is a lot more unique than doing a traditional data center is I can actually vary the type of cooling that I would like to have in this modular. So I can have one pod, right, that's doing air cooling. I can have another one doing hybrid cooling with liquid, DLC and air. And if I just want to do 100% liquid, which means fanless computing, I can do that. And if you ask me, has that been done? Yes. And then I'm going to actually show you a video of a project that we've implemented with 100% liquid cooling, and it's fanless. Last but not least, we also have another option, which is called adaptive cascade cooling, where we can recapture the heat from an existing facility that you have. And this is actually a patented HPE solution, adaptive cascade cooling, whereby we can leverage return hot water in your data center, capture that, use it as a warm water, put it through the pumps, and use that for DLC cooling. So that's another option you can get only from HPE. So what options do you get with the AI ModPod? So the form factor that you see up on the screen is you can either get a DC8 or a DC16. What is the unique feature of a DC8 and a DC16? It is a DLC, direct liquid cooled modular data center. The baby version, I call it the DC8, can do 800 kW across 8 racks, and you can configure them whichever way you want. And that's about a 20-foot form factor. A DC16, which gives you a capacity to put in a 16-rack AI cluster, and that can take you to 1.6 megawatt in an non-redundant configuration. If you want to bring this to, tier 3 enterprise type resiliency, you're talking about 1.1, 1.2 megawatt. So what are the key differentiators when it comes to the AI ModPod? HPE is the only vendor that can actually combine deploying AI, deploying high-performance computing. We provide the housing solution. We're responsible for it. It comes to you as a end-to-end package from HPE. There is no other vendor out there that's actually doing this unique, patented solution out in the industry. You can implement private cloud AI into the ModPod, and actually that also fast tracks your PC AI implementation. And we can right size the data center. So some of the pictures I was showing you earlier is that you could buy a DC8 and you only want to deploy 2 racks of PC AI, that's fine. Then you can just grow into the rest. If you want to grow into a DC16, you have that flexibility. You can just buy the entire module, and by the way, you don't have to buy all the cooling capacity and the power capacity that comes on the outside. You can grow in a modular fashion. So if you want to go buy the DC16 because it has the capacity of a 16 rack, that's great. You only want to inject 800 kW as you would in a DC-8, that's fine. Then just leave the rest of it open. Don't use it. You'll have that room to grow. What else we have? So we also have the fastest direct liquid-cooled supercomputers. I'm going to show you again an example at the end. We have more than 300 DLC patents that we actually leverage into the AI ModPod. The AI ModPod in itself has 47 patents to its name. And the one unique thing is this DLC native into the modular data center, which again, no one else in the industry actually can really come close to. They might have, similar features, but not in that hybrid cooling mechanism where we're able to vary that DLC capacity down to the rack level, as well as with the air cooling. Now it gives you the flexibility of what IT you actually implement. Last but not least, our data center facility practice is rated number 3 globally. What does that mean? That means when you look at the series of all the engineering companies in the critical facilities business and data centers, both consulting or construction companies, HPE globally is rated number 3 among the top 60 players in data center critical facilities. Okay, so why have it, right? Why do we deploy AI? So let's talk about a little bit of some use cases, right? So you can do edge computing, right? Internet of Things, IoT devices. You want to do some environmental monitoring. The one that I get actually all the time is, actually the two we get all the time is oil and gas exploration. That's a really, really common one because we have been noticing that oil and gas are taking the exploration type modeling that usually used to sit inside a core data center where you put your Cray machines, you fed it with the data, you ran the models, and you explored the fields. Now they're actually taking remotely to where the field teams are actually working on site and they need access to the data, right? So they're collecting data from sensors, they're putting that into a modular data center, they get the data on site, the data doesn't have to travel to a core data center and then back. The other one is defense applications. We are actually rated in Europe for NATO type deployments. Not exactly the DC-16 form factor because that's not transportable, but we have similar versions on a smaller scale where we can actually deploy this on a rig. It gets hooked up to a truck and the military can actually mobilize it into the field and they can move it from one location to another depending on what theater that they're operating in. So this use case that we have for Bristol University is a 5 megawatt deployment with a modular data center that is hosting upwards of 5,000 GPUs. It runs HPE's Cray EX4000. This actually is a G200 deployment with NVIDIA super chips. This is the 100% liquid cooling solution I was telling you about. What you see in the picture on the upper right-hand corner, so this small little box in the middle, that's actually 4 DC-16s put together. So in order to actually deploy all these GPUs, so we took the combination of 4 16-rack clusters, we assembled them, and we took the walls in between the DC-16 modules. It became one large modular facility, and then all around it, we put in all the MEP. And the MEP, the mechanical, electrical, and plumbing that comes along with something like this is really not that highly complex. Remember I told you about the hybrid cooling elements? It really is basic. You need a chilled water loop to do air cooling. We can, in a DC-16, we can do 600 kW of air cooling. Then the rest of that, we're dealing with a liquid cooling infrastructure. Again, that's fairly simple. You got a dry cooler, a pump skid. You plug the pipes into the DC-16. You run your hoses from the CDUs, and you have liquid cooling down to the rack. Doesn't really leave you with much. On the power side, you need some UPS to back up your network management and storage racks, and then some power infrastructure for transformers, switchgear, etc. And that's the site. So let's get into the cost, really. So I started telling you at the beginning, what are the options of workload deployment? So the decisions that customers like yourself are having, to make is, okay, fine. So I can go to the vendors, I can buy the IT, but I really have no place to deploy. So what do? Maybe I can put it in the public cloud, but then let me look at the cost a little bit. So what this table is actually telling you, this analysis that's telling you, is you can take your AI workload and you can go and trust it in the public cloud where you actually have no means of controlling it and no security, and it'll cost you 5 times as much versus if you actually deployed it on-prem with your under control, with your own security, and you have access to it, and you have no restrictions on data egress or ingress. You have none of those limitations. That's under your control. This is a true case. This is actually the use case I was just showing you at Bristol. This is roughly $300 million deployment all in. I mean, I'm talking all in. This is not the data center. This is the data center, the IT, the consulting, the implementation, deployment. This is a fully functional 5,000, upwards of 5,000 GPU deployment, 300 million. Compare that to the public cloud, you're talking that's 5 times as much. Let me show you actually a real video of what it looks like. So this is Bristol University's SMBARD, that's the UK sovereign AI infrastructure. This actually is phase 1 of what they're deploying, 5 megawatts. What I understand is phase 2 is actually going to be around double that, and then phase 3 is going to bring the whole thing up to about 30 megawatt deployment. So as you can see, HPE took control of providing that IT module Yusu at the beginning. We worked with all the contractors to help bring all the power cooling elements and deploy them at the site. We also help with the commissioning, making sure that whatever is deployed is actually going to work in the field. With that, guys, I really thank you. If there's any questions, I can take them on the side, but really thank you for attending, and please enjoy the conference. Thank you so much.